How jet engines are built for global aviation. Massive engines emphasizing scale and precision power aircraft lifting off across the world.
Okay, initiate sequence B7.
Confirmed. Proceeding with automated fastening.
Inside the aircraft engine factory. How jet engines are built for global aviation.
Keep it coming back slowly. All right, easy now, easy. Looks good.
All right, steady now. Watch the clearance on the left.
Confirmed. We're aligned with the thermal buffer. Humidity levels are stable at 45%.
Good. Cross-reference with the material specs.
Inside the aircraft engine factory, automated systems precisely route materials, ensuring peak logistical efficiency for the assembly lines.
Raw materials queue at staging zones awaiting machining. Crates shift forward steadily.
Inside the aircraft engine factory, components enter high-temperature forging furnaces, glowing with intense heat.
Following the intense heat of forging, these components enter the controlled cooling phase. This gradual temperature reduction on
High-pressure systems remove scale from metal surfaces. Residue washes away.
Once processed, the individual components are grouped into precise batches. The bins then move forward to the next phase of jet engine construction. Inside the aircraft engine factory, batches roll toward advanced machining and transformation zones. Production never pauses.
Advanced CNC machines carve components with extreme precision from solid metal blocks.
Inside the aircraft engine factory, turbine blades take shape as robotic tools sculpt complex aerodynamic curves.
Here we see the multi-axis machines rotating the parts, cutting the metal from multiple angles simultaneously.
Inside the aircraft engine factory, blade roots are shaped to lock precisely into engine discs. Tolerance checks run live.
Inside the aircraft engine factory, we see how jet engines are built for global aviation. Robotic arms polish blade surfaces to a mere smoothness.
Inside the aircraft engine factory, how jet engines are built for global aviation, large fan...
Inside the aircraft engine factory, compressor discs rotate as cutting tools refine their geometry. Metal chips eject outward.
Inside the aircraft engine factory, machined parts enter controlled heat treatment ovens. Heat-treated components cool evenly on engineered racks. Fans circulate air.
Inside the aircraft engine factory, parts are cleaned and prepped for protective coatings. No residue remains.
Finished core components advance towards secondary processing zones. Lines remain in motion.
Inside the aircraft engine factory, plasma arcs bond protective coatings to metal surfaces at extreme temperatures. Coated parts enter curing ovens to solidify protective layers. Conveyors feed steadily.
Lasers etch microscopic identification marks onto components, ensuring complete traceability without branding.
Probes glide across surfaces, measuring microscopic roughness. Readings stabilize instantly.
Precision is paramount. Here in the quality control lab, even the smallest turbine components are scrutinized under high-powered magnification.
Make sure the overlap is exactly 3 millimeters.
Got it. We need to maintain that structural integrity.
How inside an aircraft built.
Cured casings are trimmed and smoothed by precision tools. Edges fall clean.
Here we see the continuous rotation of tools machining the threads, a vital step for engine assembly.
Critical parts move into controlled clean room environments. Air curtains activate.
Is the core engine frame assembly, where millimeters matter. The robotic arms ensure perfect alignment before the next stage.
Using specialized hydraulic tools, these high-tolerance bearings are seated smoothly into the engine frame, showcasing frictionless engineering.
Inside the aircraft engine factory, how jet engines are built for global aviation. Rings of compressor blades.
Inside the aircraft engine factory, turbine blades are locked into discs using precision fixtures. Retention systems engage instantly. Inside the aircraft engine factory, the combustion chambers are positioned around the turbine core. The fuel inlet ports align with absolute precision.
The inner casings close around the assembled core, securing the delicate machinery within. Next, inside the aircraft engine factory, automated torque tools secure critical fasteners. Digital systems verify load.
Utilizing heavy-duty overhead cranes, the gleaming titanium fan module begins its slow, controlled descent toward the engine core. Inside the aircraft engine factory, reduction gearbox components connect fan and core systems. The gears mesh precisely.
Inside the aircraft engine factory, the lubrication lines are filled and primed throughout the engine. The fluid flows steadily.
Inside the aircraft engine factory, laser scanners map the engine's geometry in fine detail. Data streams in real time.
Pressure is steady at 500 psi.
Calibration complete. Data accuracy confirmed.
Inside the aircraft engine factory, how jet engines are built for global aviation, oil pressure is increased through internal.
Heating systems simulate operational temperatures across the engine. Heat gradients spread evenly.
The pressure variance on the bypass holds stable at this thrust level.
Agreed. The thermal data now aligns with the simulation. We can finalize the sequence.
As part of the full process, inspection approval markers are applied to the engine, confirming readiness for global aviation. As part of the full process, the engine exits the testing bay, cleared for shipment and handoff to the logistics team for global aviation.
Easy now, bring it down slowly.
Looks good.
All right, hold it there. Secure the latches.
These shock dampening supports are critical. They compress gently, securing the jet engine within the crate for global transport.
Inside the aircraft engine felt for jet and aviation systems.
The logistics momentum is crucial here, as the sealed crate transfers seamlessly to the dispatch line, ready for transport.
Inside the aircraft engine factory, packaged engines are cleared for warehouse storage. Pathways open forward.
Inside the aircraft engine factory, crated engines are moved onto warehouse conveyor systems for storage. The belts and rollers operate continuously.
Once completed, the engines are placed in specialized crates. Operators then use forklifts to precisely stack.
Pallets are inserted into high-rack shelving systems. Automated lifts ensure alignment.
Manifest shows serial number X-ray 12. Scanning confirmed.
Okay, all strapping is secured, ready for sign-off.
The warehouse signals readiness for distribution, with all crates accounted for.
All right, keep it steady. Bring it back another foot. Got it. Looks clear on this side.
Straps and restraints are fastened around crates to secure them during transit.
Loader, you are cleared to proceed. Approaching the sill now.
Copy that, watching the starboard side.
Inside the aircraft engine factory, The distribution phase concludes as crates are en route to international destinations.
Inside the aircraft engine factory, how jet engines are built for global aviation.
By optimizing the bypass ratio, we achieve a significant reduction in fuel consumption for this model.
How does that affect the overall thrust rating?
The fully assembled engine, a testament to precision. It stands ready for final inspection before taking to the skies. Inside the aircraft engine factory, the retail stage concludes with the product ready for delivery to clients. This facility is where the complex process of building jet engines for global aviation begins.